Hey everyone, it's your handy dandy neighborhood math geek, Kirk Weiler. I'm here with another eMathInstruction video, and I'm going to be coming out with these soon, where they're not always the polished versions that go along with a specific lesson, if those are really even polished. You know, right now you can tell I'm just kind of sitting in my office, and I'm going to talk to you today about using statistical simulators from eMathInstruction. See, we're getting to that time of the year. This is the first year of the Common Core Algebra II curriculum, at least in New York State. And teachers are probably starting to do some work with statistics. And a big kind of shift in focus in Common Core Algebra II statistics is using simulation to kind of justify and help students understand inferential statistics. Now let me just back up for a moment and let me just say this. Simply the inclusion of inferential statistics is huge in Common Core Algebra 2. So if you're a Common Core Algebra 2 teacher and your head is spinning and it's all about simulating this and justifying that and margin of error and things like that, it makes sense, right? This is Algebra 2. It's not statistics. And yet, we're given a really tough task, which is trying to get across the idea of inferential statistics using statistical simulation. So what I wanted to do today in this video, and I want to make it as short as possible, is to really kind of show you what eMathInstruction offers in terms of these statistical simulators and where to find them. So here we go. All right, so we've got three different types of statistical simulator. All right, and all of these things can be found online, both in web-based apps and in TI-83 and 84 calculator language. So right now, I'm going to actually show you where to get all of them before we get into the first program. And this is where I'm going to kind of fly around on my Macintosh. So I'm going to head on over to our website in Google Chrome. You can be in anything you want, it doesn't matter. And if you go over to our forum, if you've never been over to this forum, this is where I share a lot of our material. And I'm actually going to go down to the category of Algebra 2. All right, all sorts of different categories. Algebra 2 is a very broad one. All right, there's something that a user just posted recently. But here's an article on simulation and inferential statistics. And if you click into it, all right, what you'll find down here are all the web-based apps for everything that we do. Now, if you want both the web-based apps and the calculator work, where is that? Then you'll have to go to another post. Sorry about that. Let me find that post. Statistical simulation, additional lessons. Here we go. Statistical simulation in Common Core Algebra 2. All right. You can get all sorts of stuff in this particular article. It's based off of something that I did in Rochester earlier this year. But you can get all sorts of programs here, including the web-based apps and the calculator code. So I'm going to kind of hang out on here. Now, in order to get this calculator code onto your TI-83, 84 Plus, you got to use TI Smart Link, I think it is, or TI Link. I then open it up on my TI calculator. So let's kind of get back into that keynote presentation. So the first thing that we really kind of get into, the first type of simulation we do, is we take a normal distribution of whatever, with some given population mean, mu, and some population standard deviation, sigma, all right? And what we're going to do is we're going to randomly simulate samples taken from this population. Now, statisticians will tell you the population we randomly sample from doesn't have to be normally distributed, and I totally agree, but this is the one that we wrote. So let's talk about the calculator a little bit. Okay, that's a program called NormSamp, and that's the one that I reference in my lessons, okay? So, if you're in Google Chrome and you click on NormSamp, it will download that calculator code, but then you got to get it onto your TI-83, 84 Plus by using TI Link, okay? So what I'm going to do is I'm actually going to take a look at it in the calculator. All right, here we go. And if I go to Program, and I go down to NormSamp, hopefully, and I hit Enter. All right, here we go. It asks for a mean. So let's say that we had some mean like 50. Maybe we were measuring heights. We had a mean height of 50. Let's say we had a standard deviation of 6. Mean height of 50 inches, standard deviation of 6 inches. So that sets up our normal population. Now it asks us for our sample size. Well, whatever the problem says, Let's say that we're taking samples that are of a size 40. Okay, so 40 people in this sample. Okay, And now it asks us for the number of samples, right? So how many samples of 40 do we want to take out of this population? I'm not going to make that many because I don't want it to take too long, but let me just put in 10 samples, right? And then the calculator simulates this very easily. And what it's doing right now, and teachers can look at the code in the calculator to really see it, but it is literally randomly generating samples of 40 out of this normal population. And then what it's going to do is it's going to calculate the mean, the sample mean, for each one of those samples. And they're going to be stored in L1. Less important is it also calculates the sample standard deviations and it puts those in L2. And then you can do all sorts of things. You can actually run the statistics. So we can do one variable stats on L1. And we see that those sample means had a mean of 49.8, which is really close to the 50. I'm not going to get into the statistics right now, just talking about the simulators. And it also had a standard deviation of 0.97, which was, or 0.92, depending. And again, later on, when you get into the lessons, you can kind of look at how that relates to sigma divided by the square root of n and things like that. All right? So we can get a lot from just that program. But you can also do it in the web-based apps. So let's go back over to Google Chrome. All right. Now what I can also do is do sample normal distribution web page app. And it opens up exactly the same thing, okay, but from a web perspective. So what do we have? Population mean of 50, a population standard deviation of 6. I think I'm going to do 100 simulations this time. And what was our sample size? 40. Now here's the decimal accuracy. Now again, we're talking about the means of samples, and it depends on how big your data is. My data is going to be clumped around 50, right, because that's the mean. So I don't think I need my sample mean any more accurate than 1 decimal place. I can tell it to put my results either in rows or columns. I always put it in columns. I got to change that default, and I hit run simulation. Whoa, look at how fast that was. All of these numbers, and depending on the browser you have, you might be able to open up that a little bit more, but all of these numbers are actually sample means. They are not individual members of the sample, and that's important to understand. We're taking samples of size 40, we're randomly generating them, and then we're calculating a sample mean for that sample size of 40. These aren't members of the samples, they're actually the means of the samples. Now, if you want to get a sense for how those sample means are distributed, you just go down here, right? And you can actually see the individual X bars, especially if you only do 100 simulations. So you can really see them on this distribution. But let's just say for a moment you wanted to do more of them. Let's do 500 and run the simulation. Hey, it's done. Man, is that fast. Okay, nice distribution. But maybe you want to dig into the data a little bit more, especially if you're a teacher or even if you're a student. You can click in here and you can hit Control A. That selects the entire set of data. That's Control A. Now I can do Control C to copy. Now what do I do with that copied data set? Well, if you have Excel and you feel comfortable with it, you can use Excel. But what I'm really encouraging people to do is use what's called the Google spreadsheet. And it's actually called, let's find it, Google Sheets. You can always find it in Google under Home and Office. And the thing I love about Google Sheets, watch this. Okay, I'm going to do a new spreadsheet. And I'm going to click an A. Now remember, we did a copy. Let me just go back over there, review that, right? I did Control A to select all. And I did Control C to copy. And then I come over here and I do Control V, and there's my data. Isn't that awesome? Now, what can you do with this? Well, maybe you would want to find the mean of that, right? So I type in mean equals, and then I do equals, average. Now you might have to be like, oh, I got to put all those in. No, just click on the A. Watch this. There we go. The mean of all those means, whoops, sorry about that. The mean of all those means was 50.1. We could also find the standard deviation. I'm just putting those in as kind of a label. Equals STDEV. Click on it. That's what I want. And then again, I'm going to click on A. And those are the standard deviations. I can even click on A, come over to this little icon, insert a chart, and I'm going to choose a histogram. Look at that. Isn't that pretty? You know, I can really see how those means were distributed, right? I can think about the distribution of those means. And if you right-click on this graph and go down to Advanced Edit, you can change what's called the bucket. Now, what's the bucket size? The bucket size is how wide your bar is, right? Right now, I like it actually because it's set at every half unit. But let's say for some reason I wanted it at every 1 unit. You know, I don't really like that as much. I could even go crazy and make it every 0.1. I have to click into another field, and that's okay. But quite frankly, I really liked that 0.5. I thought that looked pretty good, right? And I can really get a sense, hit update, I can really get a sense again for how those sample means are distributed by using a freely available spreadsheet. I don't have to think really much at all about how to make that histogram. It just kind of makes it for me. All right, we'll come back to this in a little bit, but let's head back to our keynote presentation. All right, so, you know, we've got normal SAMP, we've got the web-based apps, and that's how we do a normally distributed population. Let's talk about sampling from a population proportion. Make sure you understand this. This is a little bit weird for a lot of people who haven't done inferential statistics. I've got some kind of population. Like this population, for instance, has 100 people in it. And of those 100 people, apparently 30 of them like Blue Man Group. So I colored them blue. I don't know, you know what I mean? But there's a population proportion of 0.30, right? And now the idea is I want to take a sample of that population and I want to see how those proportions distribute, right? I want to take a sample. I'm sorry. Let me explain that again. I don't think I did a good job there. I want to take a sample of that population, and I want to find out what the proportion of Blue Man Group lovers are in that sample. And of course, that's easy. I just count the number. Whoops, there goes my phone. I just count the number of blue people in my sample and divide by the total, right? And this is really easy to simulate. Yet again, we've got a calculator program called pSimulation. Again, if you go back into that article that I linked to, that's right here in terms of the calculator code. But we've also got the web-based app. Again, the calculator app, easy to use. Let me come over, let's show you. Let me go into program, let me go down to pSimulation, really easy program to use. All right, I hit enter. What's my population P? What was that, 0.30? I could just put in 0.3, whatever. What's my sample size? Let's say I want samples of size 50. Okay, and how many simulations do I want? This is actually a pretty quick program. I'm going to put in 20 simulations, enter. And what it's literally doing right now is it's taken this hypothetical population. Now the population's really big, so we can sample without replacement, all right, for you statisticians out there. So it's a huge population, and we're going to sample 50 people out of it. We're going to count how many of them love Blue Man Group, and then we're going to divide by 50. Now remember, about 30% of the overall population likes Blue Man Group. And for the kids out there, they're probably going, I don't even know what Blue Man Group is. But now look, it says sample proportions are in L1. So if I hit Stat and I go into Edit, there they are. Don't worry about L2, but in L1 I have 0.22, 0.24, 0.24, etc. So in other words, I had a sample that had where, whoops, I can't use that. But I had a sample where 26% of the people liked Blue Man Group. Right? And again, I can do statistics on that. I can do stat, and I can come into calculate, and I can do one variable stat. And I find like the mean of all those proportions was right around that 0.30, which is kind of cool. And again, standard deviations and the like. All right. Again, we also have the web-based app that does the same proportion simulator. It's sitting right here. And again, it's great because you can just come in and you can say, well, I want a population with a proportion of 0.30. What was that sample size we were using before? 50 on the calculator. Let's go with 200 samples. And I love 2 decimal place accuracy when I'm doing pSimulation. Because when I do that, I get things like 0.54, 0.27, right? I get a percent. It's really easy to think about. I'm going to put my data in columns. I'm going to hit run simulation and boom, it's done, right? And here are my results. Here they are, right? And I can kind of scan down again. I can expand if I need to, but I can also go down and look at this. Now, by the way, I don't know about anybody else. I feel like this looks a little bit funny. And one thing we're going to add eventually to the functionality of our websites is the ability to kind of change the way that these histograms play out. But again, nothing wrong with coming in here, hitting Control A for select all, Control C for copy. I'm going to put it right back into this Google Sheet I've got, because why not? I'm going to do Control V. Uh-oh. Wow, I actually forgot something. I'm going to delete all that data. Now I'm going to come do Control V, and whoa, what happened there? Well, I'll show you. But first, those are the means of all those proportions, 0.2955, very close to 0.3, and again, the standard deviation. The problem with my histogram is my bucket size is just terrible. So I'm going to go into Advanced Edit. I'm going to go down to bucket size, which I put in at 0.5. Now remember, these are proportions, so maybe I want them to go by 0.02. Let's see how that looks. Ah, there we go, right? I do update, and there's my histogram. And again, what's beautiful about this is I can really kind of examine the data, and I can see, well, I had a sample that had something as high as like maybe 0.45, something as low as 0.14, right? I can really kind of look at that distribution of data, and also I can manipulate it in terms of the mean and the standard deviation. Again, the nice thing about Google Sheets is it's free. It's just there. Eventually, I'm going to put out some Google Sheet links that people can link to. It'll make all of this processing a little bit easier, but they're not quite ready. Let's take a look at the last one, all right? Again, this is kind of dragging on a little bit. I don't want it to take too long, so don't forget that web-based app. Let's talk about the last one, comparing two treatment means. And this is truly one of the weirdest simulations, but I absolutely love it. And the idea here is that, we're trying to figure out how much variation was induced in an experiment. So one of the examples I have in one of my worksheets is I've grown things using an organic fertilizer and a synthetic fertilizer. And what these two data sets represent simply was how much did the plant grow in centimeters? How much did it grow in centimeters? All right. So we've definitely got a mean comparison. Now, here's the idea, right? When you do the two means, group 1, group 2, I should have had this in this presentation, but what happens is that the mean of the synthetic is about 3.1 inches more than the mean of the organic. Now, the question is that significant? And the way that you test this is by taking the two data sets, scrambling them up, throwing them back out into two data sets, whoopsie, and then calculating the means and seeing how much larger group 2 is than group 1. Because again, maybe that 3.1 inch difference is really not very significant. Maybe that was just due to what's called sampling variability, or even just what's called natural variability, right? So what we're going to be doing now is we're going to be taking a look at the calculator code and how this is done. Now, the way that it's done in the calculator code is, you use the problem that's called mean comp, okay? Now, one of the things about mean comp that confuses people is that you literally have to go in and you have to enter the data into L1 and L2. So I'm just kind of clearing out the data now. I'm going to clear, because those were from those previous programs. Now, really, I have actually the data sitting right here, and I'm not going to enter it all in, but I'll enter some of it in. So I've got the 6, 8, 10, I'm entering the data from that first treatment, 12, 12, I'll put the 3 12s in, and then I think I'll stop. By the way, the two data sets do not have to be the same size, okay? So now let me put in the other data, 9. I've got my dog Lego here, and he's asking to be pet, so it's kind of tricky. I've got 12, and I've got 12, and I've got 15. So let's say this was all the data that we had in the experiment. This was it. Each one of them just had 6. Well, now what happens is when we go into the program and we go down to mean compare, all right, all it asks us is how many simulations we want to do, because it's going to take, each one of those data sets had 6 elements in it, 6 results. It's going to take those 12 results, scramble them up, and throw them back out do a mean, subtract, and see what the difference between the means is. And it's going to do that as many times as I ask it to. I'm going to ask it to do it 10 times, that's it, because this simulation actually can take a little bit. It's not taking too long now because we don't have much data in the two data sets, just 6 elements each. All right, there we go. It says differences in sample means are in L3. So now if I go back into stat and I do edit, I can actually see those simulated differences in the sample means. All right, there they are. Okay, and then we can do stuff with them. Specifically, what you really want to look at there is the distribution of those things. But we can really see that well on the web-based app. So let's go back into the web-based app. Statistical simulation, here it is. Difference in sample means, web-based apps. There's the calculator code. If I click into that, I have to, in sample A and sample B, put in that data. Now, it's kind of annoying, the idea that you might have to literally enter the data by typing in one number and typing in another number. Kids don't like it, teachers don't like it, but it's easier than that. Watch. Watch as I go to the PDF. This is just the PDF, sure, on a Macintosh, but whatever. It's the PDF of that lesson. I highlight that data in the PDF. I hit Control-C for copy. All right. Go back into Chrome. I hit Control-V, and look, there's the data. Don't forget to hit the Add button. A little pop-up will kind of say, yeah, good job. You got to hit the Add button. Go back here. I highlight my second data set. I hit Control-C for copy. Let me go back into Google Chrome. I hit Control-V for paste. I add. Don't forget to add. Those two data sets are now added. Okay, number of simulations, I'm going to simulate 100 times. It's going to scramble up this data 100 times. And the decimal accuracy, again, what it's doing is it's going to calculate two means every time it scrambles up the data. You like my scrambling? It's going to calculate the two means and it's going to subtract the means. I don't think I need that any more than 1 decimal place. That's just me. Nicer results. And I run my simulation. Now this simulation, even online, takes a little while, but not that long. And here they are. Now remember how I said originally that the original difference in the two means was about 3.1 inches? Well, look at how rare that is. In fact, by chance alone, it only happens roughly once out of those 100 times. Right? 100 simulations, and our observed difference, which was around 3.1, was only exceeded once, which basically means that there's only about a 1% chance that the variability that we saw wasn't due to the induced nature of the experiment. In other words, yeah, we gave some plants synthetic and we gave some organic. Just like before, if that histogram doesn't do it for you, you can put your cursor in here, hit Control-A for select all, Control-C. Let's go right back into our Google spreadsheet. I'm going to delete the data in here. I'm going to put Control-V, and there's that distribution, right? And again, if this is ugly and you're like, man, I don't know what was going on with the bucket size there, you could go back into the advanced edit. Should I make my bucket size 0.02? Wonder what it would look like with 0.5. Oh, I like that. That works for me too, right? And again, the beautiful thing about that histogram is I can really quickly look at it and go, boy, we almost had nothing that was in that 3.1 inch range, right? You can, of course, also just scan the data. You can look at the data itself, right? And you can see, there are shortcut keys, that there was only this one particular element that was above the observed difference we saw. All right, let's get back to our keynote. Hello, web-based app. So, those are our offerings from eMathInstruction. It's how they work on both the calculator and how they work in the web. Also, how you can use Google Sheets to kind of look at the data and at the distribution of data. I know as a classroom teacher, obviously using things like Google Sheets and any of the simulators, whether it's on the web or on the calculator, it takes time. It takes time to get the programs on the kids' calculators. It takes time for them to understand what in the world's going on. And really, the most important thing for them to do is to understand how to interpret the results. And that takes like some real probabilistic thinking. And yet, the Common Core standards are very clear. Students will use statistical simulation to understand things like margin of error and treatment effects and things like that. It's a tough task. And if you're a Common Core Algebra II teacher, I hope that this gives you some tools to help you out. For now, though, let me just say bye-bye. Again, this has been Kirk Weiler for eMathInstruction. And don't you forget to keep thinking and keep solving problems.